In this lesson or review, we're going to look at finding the least common denominator of rational expressions. And this is going to be important for future lessons in the next lesson, in the lesson after that, because you will be adding and subtracting rational expressions. And in order to do that, you have to be able to find the least common denominator. So as you find the least common denominator, there are basically three things you're going to need to do. The first thing you have to do is this. You're going to factor each denominator completely. And for the factors that occur more than once, you should express this factor as a power. You don't have to, but it does help. So for example, when you factor one denominator, and let's suppose you have x minus 3 times x minus 3, it is helpful if you write it as x minus 3 squared, because that exponent is going to be important. Then once you find once you do step one, which is to factor the denominator, the next step is this. You're going to list all the different factors other than one that appear in any of the denominators. When the same factor appears in more than one denominator, you're going to write the factor with the highest power that appears. And then step three is that the least common denominator is the product of all of the factors that you've listed in step two. All right, so let's go ahead and look at how this applies to some examples. Okay, so the directions will say this. Directions will say for each of the following, indicate the least common denominator. So let's look at number one. So number one, let's suppose we have 2 divided by x, let's redo this. 1 divided by 5 plus 3 divided by y. Now remember, all I'm interested in doing is finding the least common denominator. I don't care what the numerators are. It's the denominators that I'm interested in because if you recall, in order to add or subtract fractions, in this case rational expressions, your denominators have to be the same. And so in order to do that, you've got to find the least common denominator. So first thing we're going to do is going to factor the denominators. Well, if you notice that there's nothing I can do with the denominator 5. I cannot factor that. For one thing, it's prime. Secondly, it's a monomial, right? It's a monomial. Same thing here. Y is a monomial. So step one, there's nothing to do in step one. So in terms of factoring, there's nothing to do there. Then the next thing we're going to do is this. We're going to list all the different factors that appear in any of the denominators. So for example, my factors that appear are these. So I'm going to write this as separate factors. So the first factor you see is a 5. So I'm going to list it. The next factor you see is a y. I'm going to list it. Okay, so those are the factors that appear in the denominators. And so therefore your least common denominator will be the product of this. So your least common denominator is 5y. All right, number two. Number two, we have 3 divided by x squared minus 5 divided by 7x. All right, so 3 divided by x squared minus 5 divided by 7x. So if you notice in this case, again, you're dealing with monomial factors in both of these. So in terms of x squared, there's nothing I can do there except leave it as x squared. And the same thing for 7x. So now what I want to do is in step two, is I want to list all the different factors that I see. So one of the factors I see in the first denominator is an x, but there are 2 of them, right? There are 2 of them. And so in the other denominator, I see another factor of x, but there's 1 of them there. So in step 2, it says this. It says, when the same factor appears in more than one denominator, write the factor with the highest power that appears. So I see a factor of x, I see a factor of x. The highest power I see is 2. So my factors, my different factors are going to be x squared, comma, and then the other factor I see is a 7, right? Now this is a 1 right here, this is a 7, so the least common denominator of 1 and 7 is 7. And so therefore your least common denominator of x squared and 7 is going to be 7x squared. And always put the coefficient in front. So remember, the least common denominator is a product of these different factors that you see in the denominators. Okay, so that's your least common denominator. This is not your answer. If it says find the least common denominator, what I have boxed off is the answer. Keep that in mind. That's the answer. Number 3. Number 3, we have 1 divided by 10x cubed y plus 5 divided by 27x squared y cubed. Okay, now let's talk about the different factors that I see. For one thing, in step 1, we have to factor the denominators completely. Well, keep in mind, if you know, just like the first two, these are monomial factors. So in terms of factoring, there's nothing I can do there. If I want to, I can write 10 as 2 times 5 as a product of prime numbers, and then 27 would be 3 cubed, right? 3 times 3 times 3. So if you want to, you can do it that way. So you can write 10 as 2 times 5, and then 27 as 3 cubed. Okay? And so if I look at the different factors, I have a factor of 2 here. I don't have any here, right? So I've got to include that as one of my factors I'm going to have in my least common denominator. The other factor I see is a 5. I don't see any other 5s here, so I'm going to list it as a factor. Just one, 5 to the first power. Just one factor of 5. Then I see, let's just deal with the numbers for right now. Then I see a 3, but there are 3 of them. I don't have any 3's here, so I'm going to have 3 to the third power. Remember, always use the one with the largest exponent. And then my variables, I have 3 factors of x here. I have some x's here, but there's only 2. So remember your least common denominator, when your factors appear in more than one denominator, you got to use the one with the highest power, the highest exponent. So I have x occurring as factors here, x occurring as factors here. There are 3 of them. There are 2 of them. I must use the largest one, 3. So x cubed, comma. And then I have y's in all of them, right? I have y's. So I have 1 factor of y here, 3 factors of y here. You got to use the one with the largest exponent. So you're going to use 3 of them. Don't put y to the 4. Don't count them. Don't say there are 3 here for the x's. Don't say there are 3 here and 2 here and say x to the 5th. Don't do that. That's not the least. That's a common factor. That's a common denominator. That will be a common denominator, but it's not the least. Always use the least. If you don't use the least, it makes your problem in the next lesson more difficult to deal with. Always use the least. That's why we talk about the least. That's why you're learning about the least common denominator. So don't add these up. Don't say 1 factor of y plus 3 factors of y will give me 4 factors of y. Don't do that. Okay? You got to use the one with the largest exponent to give you the least. So it'll be y cubed. And so therefore your answer, 2 times 5 times 27. So that is, let's see, 2 times 5 is 10. 10 times 27 is 270. So 270. And then x cubed, y cubed. X cubed, y cubed. Okay? All right, so that's going to be the answer for number 3. All right, number 4. All right, in number 4, let's suppose we have 5 divided by x minus 7y divided by x plus 3. So if you look at those two denominators, now remember in 1, 2, and 3, those are all monomial factors. In number 4, this is a monomial, this is a binomial, but I cannot factor this binomial any further. Okay, so I'm going to list my different factors that I see. So one of the factors I see is an x. I don't have any factors of x here, so I'm going to list it. X to the first, only one factor. The next factor I see is x plus 3. I'm going to list it. Okay? Then the least common denominator, your least common denominator is the product of these. Now be careful how you write this. Always put the monomial in front. So you can write this as x times x plus 3. Make sure you put that in parentheses as x plus 3 because it's a binomial. Notice I didn't have any parentheses here because those are all monomial factors. Here that's a binomial. So this, when you're finding the least common denominator, you're going to say this times this. So this, that's a binomial or a trinomial or any polynomial other than one term, you're going to put that in parentheses. All right, number 5. we have 7 divided by 3x squared minus 6x plus x squared divided by x squared minus 4x plus 4. Okay? All right, so let's go ahead. Now, notice in this case I have a binomial and a trinomial, and in order, and remember the first step says I've got to factor each denominator. So to factor this first denominator, the GCF is a 3x. I'm going to write this as 3x times x minus 2. Okay? Over here, I can factor this as x minus 2 times x minus 2, which becomes x minus 2 squared. So remember, this little part said this. This little part said, for factors that occur more than once, you should express this factor as a power. For example, x minus 3 times x minus 3 should be written as x minus 3 squared. Now, the reason you might want to do that is this, and we're going to get to this in a little while. Let's take care of the monomial factors first. I have a factor of 3 here. I don't have any factors of 3 here, so I'm going to use one factor of 3 as my factors, comma. Then the other factor I see is this x. I don't see any other factors of x here, so I'm going to write down the x. The next factor I see is an x minus 2, right? Only one of them though, right? So x minus 2 to the first power. But I have some here as well. But there are two factors of x minus 2. According to step 2, use the one with the highest power. Use the one with the highest power. So I'm going to use two factors of x minus 2. And so therefore your least common denominator is the product of all of these that you see. Make sure you understand the least common denominator is a product of these. So you're going to say 3x times x minus 2 squared. Do not put any commas there. Don't put any commas in your answer. Notice nowhere did I put any commas in my least common denominator. Your least common denominator is a product of all of the different factors that you see in your denominator. You see a 3? There's a 3 here. See an x? There's an x here. See an x minus 2? There's 1 here, 2 here. You're going to use 2 of them, the one with the largest exponent. Don't put a 3. Don't do this. Don't say, well, there's 1 here, 2 here, I'm going to put 3 here. That's no longer a least common denominator. That's a common denominator. And if you were to actually add these up, it would make it extremely more difficult to do. The least common denominator is what you always want to use when adding or subtracting rational expressions. Number 6. Number 6, let's suppose we had 3x divided by x minus 4 minus 2 divided by x plus 2. Okay, so notice that in my denominators I cannot factor any of these. These are binomials. The GCF is 1. There's nothing else I can do. So my different factors that I see are x minus 4, comma, x plus 2. And so therefore my least common denominator will be the product of these. Now be careful. Do not say this. Some students do and they get themselves into trouble. Don't say that, because if you look at this, if you write it like this, mathematically this means that the only two things you're multiplying together is 4 and x. But technically, mathematically, you're multiplying this and this together, so you have to put that in parentheses. All right, so keep that in mind. All right, so that was number 6. Let's look at number 7. Number 7, let's suppose we had this problem for number 7. All right, number 7, we have 3x minus 1 divided by x squared minus 2x minus 24, subtract 4 divided by x squared minus 16. All right, so again, we're going to factor the denominators, and I can factor these because this right here I can factor as x plus 6, x minus 6 times x plus 4, right? And over here, this is x minus 4 times x plus 4. That's the difference of two squares. All right, so my different factors I see. So once you factor, the next step, the next step is to list the different factors. So once you factor, list different factors. So one of the factors I see is x minus 6. I don't see any x minus 6 here, so I'm going to list it once. Okay? The next factor I see, and you can put this in parentheses, by the way, if you want to. So you could say x minus 6, parentheses, comma. The next factor you see is x plus 4. I see one here. I see one here. I'm only going to include one. Don't say two because you see two of them. That's no longer the least. It becomes a common now. So remember, when the same factor appears in more than one denominator, write the factor with the highest power that appears. Well, they both have the same exponent, right? X plus 4 to the first power. X plus 4 to the first power. So you only use x plus 4. Then the next factor I see is x minus 4. So I must use it, x minus 4. So notice, and then I have my x plus 4, which I already have. So notice that all my denominators, these are the three factors I see in my denominators. So the least common denominator will be the product of all these three different factors that you see. So you can write the answer as x minus 6 in parentheses times x plus 4 in parentheses times x minus 4 in parentheses. All right, number 8. So let's suppose number 8, I had 2x minus 1 divided by x squared minus 2x plus 1 plus 6x divided by 2x squared plus x minus 3. All right, so again, the first thing you have to do is factor the denominators. So I can factor this as x minus 1 times x minus 1. And I can factor this one as 2x plus 3 times x minus 1. Let me make sure that's correct. Yep, that's correct. So therefore the different oh, and by the way, see how this is listed twice? It's a good idea. You don't have to, but it's a good idea to write this one as x minus 1 squared. All right, so now my different factors I see are these. Listen carefully. I see an x minus 1 occurring here. There are two of them. I see one here, but there's only one. So according to finding the least common denominator, you use a 1 that has the highest power. So there's 2 here, 1 here. I must use 2. Okay? Then the next one I see is 2x plus 3. There's 1 here. I don't see any here, so I must use this 2x plus 3 to the first power. Okay? I have an x minus 1. I already dealt with it. That's included in this one. So your least common denominator is the product of these. So you're going to say x minus 1 squared times 2x plus 3. Or if you wanted to, you could put 2x plus 3 first. Multiplication is commutative. So you could have said 2x plus 3 times x minus 1 squared. Now some students will write it like this, and nothing wrong with this. Some students will say, could I write it as 2x plus 3 times x minus 1 times x minus 1? And the answer is yes. So if you don't want to write it as x minus 1 squared, you can write it as x minus 1 times x minus 1. It does not matter. Okay? All right, so that was a quick review on finding the least common denominator of two rational expressions.